Hello everyone, once again we are continuing with L'Hopital's rule, and in this video we'll be looking at a few example or rather application of the L'Hopital's rule. But just a quick revision, L'Hopital's rule states that if we want to determine this limit, but however it gives us a value of 0 over 0 or infinity over infinity, then the limit of this graph can also be equal to the limit of the derivatives. So now let's look at this case. Here in this example, they said that we need to determine what the limit of x to the 3 minus 1 over x to the 4 minus 1 as x tends towards 1. So if we try to plug 1 here, we'll get the value of 1, and then 1 minus 1 is 0. And here again, if we try to plug 1, we'll get a value of 1 minus 1, which is 0. So then now here we are getting a case of a limit being equal to 0 over 0. Then since this is the case, we are able to apply L'Hopital's rule, and L'Hopital's rule says that the limit of this quotient would then be equal to the limit of the derivatives. So then the derivative of this would then be equal to, so the limit as x tends towards 1, the derivative of this will become 3x squared over the derivative of this is 4x to the 3. So then now you see that now if we plug 1 here, we are getting a value of 1 squared over 1 to the 3. And then the final answer is 3 over 4. So do you see that even though that the initial quotient then's limit was 0 over 0, when we determine what the derivative is according to L'Hopital's rule, we were able to determine that the limit is then 3 over 4. So we are done with the first example. Now let's look at the second example. So in this second example, once again, we are asked that we need to determine what the limit of ln x over the cube root of x is as x tends towards infinity. So then here on the side, we've made a sketch available of ln x and that of cube root x. So then we see that ln x as x tends towards infinity. So let's write this on the side. The limit of x, the limit as x tends towards infinity of ln x over the cube root of x, right? So then now let's look at this case. Ln x as x tends towards infinity is infinity because this will go on like that. And then now if we look at this cube root of x as it turns towards infinity, we'll move towards that side, this also turns towards infinity. So now once again we have a case whereby the limit is then equal to infinity over infinity. Then it means we are able to apply L'Hopital's rule, and L'Hopital's rule states that this limit, the limit of this quotient, is also equal to the limit of the derivatives. So then we will try to determine what this is. So the limit as x tends towards infinity, right? And then now we will determine what the derivative of this is. The derivative of that is 1 over x over the derivative of this would then be equal to a third x to the power minus 2 over 3, right? So if we try to clean this a bit, we would learn that the limit as x tends towards infinity of 3 cube root x. So we're getting this value. So now we see that since this value is small, it's 3, and this value will tend towards infinity, it will be very large, then this means this turns towards 0, because we would essentially be having a value so small and a value so large at the denominator such that this limit would then be 0. So do you see that L'Hopital's rule basically helps us determine the limits of indeterminate forms, because initially, once again, we had a case whereby we are unable to determine what the limit is. But then when we determined the limits of the derivatives, it's simplified to 0. So to challenge yourself, then you would attempt to draw what this is. Maybe on one of the softwares, online search, online sketcher, and try to sketch this. And you'll see actually that when you draw this, once again, you'll see that it turns as x turns towards infinity, this graph will turn towards 0, meaning that L'Hopital's rule stating that this limit is equal to the limit of the derivative is true. So to challenge yourself, go and sketch this graph on an online sketcher. You will see that indeed this limit of this is the same as this, and it will turn towards 0. So then now let's look at this last case. This is then essentially, it's important because it highlights when or when not to use L'Hopital's rule. So if then we would try and apply blindly L'Hopital's rule without checking the conditions. For instance, we looking at this without then determining whether it's 0 over 0 or infinity over infinity. So let's say if we blindly applied L'Hopital's rule here on this particular example. So then this means then we would would say the limit as x turns towards pi on the left side of sine x over 1 minus cos x, right? So applying L'Hopital's rule means that we would then determine the derivative of this, which would then be, the derivative of this is then cos x. The derivative of this would then be equal to sine x, the limit as x tends towards pi on the left side. So then now the limit of this, right, if you look at this graph, the limit of this as we approach pi on the left side, we see that this goes towards minus infinity. It goes towards minus infinity because this is the graph of cos x over sine x. So approaching pi from the left side then means that this graph turns towards infinity, minus infinity. But now this is not true because there are conditions at which L'Hopital's rule is applied. We need to have a case whereby it's 0 over 0 or a case whereby it's infinity over infinity. But now it's not true for this case because if we look here, this is the graph of sine and this is the graph of cos, right? So remember that we want to determine what this limit is. So then let's determine what it is. The limit as x tends towards pi on the left side of sine x over 1 minus cos x. So sine x approaching pi on the left side, we see that this is sine x, right? Approaching pi on the left side, it goes towards 0. So we have here a case of 0 over 1 minus cos, though. Approaching pi on the left side tends towards minus 1. So minus 1. So we then have a case of this limit approaching 0. So do you see that the limit of this wasn't undefined? So in order to apply L'Hopital's rule, you needed to check first whether is it type 0 over 0 or infinity over infinity. If one of these cases exist, then you will be able to apply L'Hopital's rule. So you cannot, by just looking at this quotient, immediately apply L'Hopital's rule. It then means that you will get a wrong value of what the limit is.